All right, let's look at the matrix operators and the linear transformations. All right, so let's look at the matrix multiplication. Let's say you have a matrix M, so here M. If you apply a matrix M, matrix multiplication to, say, vector x comma y, then you just go through the matrix multiplication and you get, of course, ax plus by and cx plus dy, right? And as you know that the matrix multiplication is satisfy the linear operator, you know that m times a vector v plus vector v2 is m times a vector v1 plus m times vector v2, and also the constant multiple m times k times v is k times mv, right? So we know that from here it satisfies. So this is a linear operator. So we can call a matrix multiplication a matrix operator. Right? Also, the matrix multiplication takes vector and then spits out another vector. So you can think of it as a transformation. So transformation is any function from Rn to itself. In this case, it's a 2 by 2 matrix, so it's a transformation on R2, so into itself. All right, so since it's a matrix is a linear operator, and also you can think of it as a transformation, so it makes sense to call matrix operator linear transformation, right? So this is the linear transformation. All right, since this is a linear operator at the same time a transformation. All right, so let's look at a simple example. All right, let's say you want to find or construct a matrix which reflect all the points about the y-axis. Right. So we know. So I already drew a picture. Right. So you take any random point x comma y. If you reflect it about the y-axis, the change we have to make would be the x-coordinate, right? X-coordinate has to be negated, and the y-coordinate stays the same, right? So what matrix does that, right? So we want to come up with a matrix. Let's say, so I'm going to have, say, capital X comma Y, right? So that's the resulting point, right? So we're trying to get, so here we just have to negate the x component and keep the y component as it was, right? So this is actually the same thing as this matrix multiplication. All right, so you have to, let's see, you have to negate x. So you're going to have at least, there's -1 should be there, and there's no y involved there, so it's going to be 0. Right here, y, there's no x involved, so it's going to be 0 there, and you have that. All right, so we have a linear transformation which reflect all the points in R2 about the y-axis. So this is the corresponding matrix there. So this is the matrix operator, which does exactly that. All right. So that's a simple example of a linear transformation, which does a reflection about the y-axis. Right? But linear transformation, you can think of it as a matrix multiplication or a matrix operator, since it's a linear operator and at the same time it's a transformation. So we can call it linear transformation. All right, that's it. I hope that this was clear.